All right, let's dive into a challenge that is absolutely massive for so many of us right now. How do you take a chaotic pile of documents and turn it into a smart, reliable knowledge base using AWS? We're going to break down how to build a system that's truly ready for production.
This is the question, isn't it? Sooner or later, every engineer trying to build a real generative AI system runs smack into this. It's one thing to build a cool demo that works on your laptop, but it's a completely different ballgame to build something a business can actually trust with its critical data.
Well, the secret sauce here is building a really solid RAG indexing pipeline. And RAG, that just stands for retrieval-augmented generation. But honestly, the best way to think about it is as an automated factory. Raw, messy, unstructured data goes in one end, and out the other comes clean, structured, searchable knowledge, all prepped and ready for your AI model to use.
But here's the thing. To build this factory right, you have to start with the right mental model. The single biggest mistake people make is treating this like one giant monolithic process. It's not. You really have to think in terms of three totally distinct pipelines.
That's right, the whole GenAI data lifecycle, from start to finish, it's really best understood as three separate but interconnected pipelines. Nailing this structure right from the beginning is absolutely the key to building a system that's manageable, scalable, and, most importantly, reliable.
So let's break them down real quick. First, you've got the ingestion pipeline. Its only job is to get your raw data and clean it up. Second is the indexing pipeline, and that's going to be our main focus today. This is where we chop that data into pieces, turn them into vectors, and get it all organized. And finally, there's the runtime pipeline, which handles the user's actual question and generates the final answer.
Okay, so to really bring this indexing pipeline to life, we're going to follow a single document on its journey. We'll watch it go from just a raw file upload all the way to becoming a searchable piece of knowledge in our system.
And to make this whole thing a bit more memorable, let's use an analogy I really like. Your pipeline is a sushi conveyor belt. S3 is where the raw fish, your documents, get dropped on. Each step in the process is a station that preps it. And if even one of those stations is sloppy, well, the result is digital food poisoning for your users. Not good.
So the journey kicks off the second a document lands in an S3 bucket. That immediately triggers our workflow. The first station is normalize, where we pull out all the raw text. And yeah, if it's a scanned PDF or an image, we use optical character recognition, or OCR, to read it. Next up, the chunking station slices that big block of text into smaller, more meaningful pieces.
Now, let's be super clear about chunking. This is not just splitting a document every 500 words. No way. The strategy you choose here is critical. Whether you do it based on the meaning, that's semantic, or the structure of the document, it's all about making sure you keep the right context together. Get this wrong, and your answers will be terrible.
All right, next up on the conveyor belt are the final stations. The embed station uses a model to turn each text chunk into a string of numbers, a vector. Then, those vectors get loaded into our vector store. But we are not done. And this is a step that people so often miss, validation. We have to run automated queries against this new data to make sure the quality is good before anyone can see it. Only after it passes those checks do we actually deploy the index.
Okay, so we know the steps on the conveyor belt. Now we got to talk about what's actually running the belt itself. And I really can't stress this enough. A simple script that just runs these steps one after another is absolutely doomed to fail in a real production environment.
And this slide just lays it all out, doesn't it? A simple script is just fragile. It's a house of cards. The first little error and the whole thing crashes. There are no retries, and good luck figuring out where it failed. A real production workflow, on the other hand, something orchestrated by AWS Step Functions, is resilient. It handles errors, it knows how to retry things, and it gives you this perfect, traceable map of exactly what happened.
And a huge part of that resilience is having a smart failure strategy. Instead of just one giant error bucket, you use multiple dead letter queues. It's like sorting the mail. Documents that fail because of bad metadata, they go into one queue. Failures because of a security or governance issue, they go to a completely different one. This makes fixing problems so much more efficient.
Okay, so our sushi factory is humming along, but now we have to talk about the health inspector. I'm talking about security and data governance. This is not some afterthought you tack on at the end. It's a gauntlet that every single piece of data has to run through.
And this is probably one of the most critical questions you have to answer. If personally identifiable information, PII, finds its way into your knowledge base, you've got a massive, massive problem on your hands. So how do you stop it?
Well, AWS gives you this really smart two-layer defense. First, you use Amazon Massey to automatically scan your S3 buckets at the source, finding sensitive data before it even gets on the conveyor belt. Then, as a second layer of defense, you use a service like Amazon Comprehend PII to find and actually remove sensitive info from the text itself before it gets chunked and turned into a vector.
All right, here's another absolute deal breaker for pretty much any real-world application. If you're serving multiple customers, multiple tenants, you have to have an ironclad guarantee that Clinic A's data will never, ever, under any circumstances, leak to Clinic B.
And the answer, again, is all about having layers of defense. First, at the infrastructure level, you have strict access policies on your S3 buckets. But just as important, you tag every single chunk of data with a tenant ID. This lets your vector store apply a filter, so a query from Clinic A can only see data that belongs to Clinic A, period.
Okay, listen up, because this is a super important gotcha that trips a lot of people up. You might think, oh, I'll just use a feature like Bedrock guardrails to protect me. But here's the thing. Guardrails only scans the user's initial question and the model's final answer. It does not sanitize the raw data chunks your system pulls from the vector store. Your indexing pipeline is your only line of defense for that retrieved data.
So, we've built this robust, secure pipeline. Awesome. Now we have to be the mechanics and keep the thing running smoothly. And that means building in observability from day one and knowing exactly how to fix things when they, inevitably, break.
And this checklist? This is your dashboard. These are the vital signs you absolutely have to be watching. You need to know your success rates, your throughput, your error rates for each stage. You need to set up alerts for weird things, like if a document suddenly creates 10,000 chunks. And you have to measure freshness. How long does it take for a new document to actually become searchable?
And seriously, this slide is pure gold. These are the real-world problems you will face. Your index is going to get stale. The fix is to version your documents. You might have a cross-tenant leak. The fix is to make metadata validation mandatory in the pipeline. You're going to get garbage results from bad OCR. The fix is to add quality checks and confidence scores.
Which brings us right back to our sushi conveyor belt. Building a production-ready GenAI pipeline isn't just about plugging some services together. It's about designing a system with the discipline and care of a master chef, making sure every single piece of information you serve to your users is fresh, accurate, and safe. Because anything less, and you're just serving